Well, no, it was
No.
created because there are people that are very racist.
Yeah, they did. That's true. Yeah.
Part of it was the fact that it was people on horseback that were delivering ballots had to go significant distance in the sense they had committees.
Yeah, I've heard that. Well, you know, there's a lot of different analogies. Anyway, it's very interesting stuff. When I was a kid, I thought American history was really dull because I was reading very watered down propaganda. When I get back to see what really happened, it's very interesting. And it makes me feel a lot better about the current madness with Trump. This is nothing. We've been through so many things that were 10 times worse than this. It's not like everything was fine and then Trump ruined it. Yeah. This is really not at all as bad as it gets. I remember the Vietnam War was much worse. We've been through a lot of times that are much crazier than this.
People realize things like COINTELPRO, the FBI program of mass surveillance, some crazy things.
Well, yeah, no, Trump did seem sort of shocking the way he lies all the time, but you know, I thought it was funny. The newspapers didn't even used to pretend to be impartial. There's one newspaper had a little poem as their byline, and it said at the end, you know, the stuff we say is not wholly true, but not wholly a lie either. That's as close as they get. It's sort of like Fox News, you know. Anyway, it's
World War II, we were allied with Stalin.
Yeah, and before that with Napoleon.
Yeah, how much worse can you get?
Well,
Stalin.
Allied with Stalin.
Well, for instance, too, also a big one is that we fight Taliban in Afghanistan, one of our biggest allies in the Gulf of Saudi Arabia. Saudi Arabia is funding the Taliban.
Well, I know. Anyway, I've got a few minutes to talk about other news things. Let me bring up a few.
There was a
Stalin committed mass genocide. He was just as bad as Hitler.
Stalin did not put people in gas chambers.
He put in the gulag stuff.
Well, yeah, but you know, the United States.
Well, anyway, here's a couple of news articles I thought I'd mention before we get down to the normal stuff. This one is pretty amazing. So cryptocurrencies have this weakness that you have this private key you have to save. And what a lot of people do is put it in exchanges, and then people steal the private key. So the alternative is cold wallets, and this guy put it in a cold wallet, and then he died. And all that stuff is just gone, apparently, 145 million. Now, I don't know if this really happened or if they're just lying as they steal it. But one thing about these public blockchains is if they do take the money, people will be able to see it go. It's probably really gone. And I think I've read before that more than 7% of all Bitcoins have been stolen, and more than 1% of all Bitcoins have been destroyed in this fashion. Someone lost the private key and they're just gone. 7% has been stolen. And like more than 1% has just been destroyed. Yeah. There's no crack. No, they use proper cryptography. It's based on SHA-256. No, it's based on uncrackable protocols. If you actually used a random key, nobody's ever getting in there. No, you can never do a brute force. Brute force can never crack even 128 bits of randomness. The only thing you can do is if you use a memory wallet based on a password, you can guess the password. But if you really used a random number generator, then you're never getting in there, I think. There are arguments about this. No one knows. There are some strong physical arguments that we'll never be able to crack a 128-bit key because it would take more entropy than the whole universe has. But other people have different ways. No one can predict the future very well. We don't know. But certainly nobody can do it now as far as anybody can tell. So that money is just gone, apparently. Now, what they have done in the past with other blockchains is they've convinced the organizers of the blockchain to have a do-over and put the money back in the wallet. That's happened on Ethereum. They could do that. They could cancel the entire ledger and modify it, but Bitcoin has never done that, and I don't think they're going to do it. Ethereum actually did that at least once. And so did the London Stock Exchange and the New York Stock Exchange. Decide, oh, this is horrible. We're going to just roll back time a couple days and have a do-over.
I'm not a big fan of cryptocurrency.
Yeah.
1% doesn't seem that bad. I can only imagine like paper currency, at least 1 or 2% of it must disappear.
Yes, that's a fair statement. Yeah. Yeah.
Like in the laundry and like all kinds of laundry.
Yes, that's a good point.
Well, most currency is generated is physical dollars.
Anyway, so this guy is starting a project to make designer babies, and for somebody leaked out his semi-secret product, his PowerPoint, sort of like when Snowden leaked out the PowerPoints, the NSA hacking everybody. He is claiming they're going to make billions of dollars by having tens of thousands of designer babies made for people under contract. They're trying to get funding, taking a small little testing. Then they're going to have, he's really planning to sell custom babies to people. This one comes over and over and over. It's like the Fountain of Youth. Another one I heard, what I thought was pretty funny, there was from 20 years ago, there was a doctor who would sell you sperm from like Nobel laureates and Olympic prize winners so you could have super babies. And he sold this for like 10 years. And then it turned out it was all just his sperm. He was just lying. It wasn't really from the athletes or the geniuses or any. I know. Then they like finally punished him and he killed himself or something. But you know, it makes me think that's what's going to happen. They're going to tell you it's a super baby and it's going to turn out to be nothing. But anyway. Canada, I think. Yeah, I think, but I'm not sure. Anyway, we'll see what comes of it all. I know the guy that did it in China is in big trouble. These guys are like most startup people, are sort of glossing over the legal problems. Oh, we'll get over that somehow. Like, but
How much do they know?
Well, that is a very good question. People get these DNA profiles. My friends sign up to like 23andMe, and he gets his profile telling me he's like 5% Indian and 10% black or something. And then next week they send him a revision. Now he's only 1%, maybe even 20% black. I say, and the people in the field, they've interviewed him, they say, this is a total waste of time. You do as well with astrology or tea leaves. You can do your DNA, but no one has any idea what it means. And in the same sense here, not except for a few diseases, a few very general problems, you know, in general, like what would make you faster and stronger and smarter, they don't really have a clue. Yeah.
After CRISPR-Cas9 came to right, and genes was insane. Did you hear about that guy in Korea that's buying and brushing off to try to revive the man species?
No, but that's I saw the movie, Jurassic Park. Bringing back old dead forms of life, that might work. That's reasonably plausible, because you're not. Yeah, I mean that's reasonably plausible, but improving humans is the stuff of real science fiction nightmares. And
because intelligence is so complicated in terms of interaction between genes.
Yes, and I think if you could choose to make people the way you want them to, you would just make them all agree with whatever your current bigotries are, and it wouldn't really be the best thing. You know, it's like whatever's fashionable now is what you get. And you'd probably decide later that you'd overlooked some important part of human life. You know, I'm like, being smart is not everything.
I have a question.
Yeah.
Lastly, do you think the REST file URL has problems?
What has problems?
REST file URL.
Oh, well, I don't know if it has problems. It's a little funny. The problem with the REST style URL, which we have back here someplace, is that it's hard to tell what it means. That's all. Yeah, there's, well, I don't know. Where the heck is my REST style? Did we go down here? I don't think it. Somewhere in this thing is the REST style. Let me see if I can find it. We went through this. And there it is. There's REST. Yeah, so the only thing about this is it is ambiguous. You don't know if there's a folder named search and a subfolder named Ford and a folder named Pinto, or if the search is the file and then Ford and Pinto are parameters. It could be either way. So if you're an intermediate device, like a web application firewall, this is hard to interpret. And this is the fundamental problem with the web, and we're going to see a lot more of this today. You have many different devices speaking different languages. You have many different dialects of languages flying around. So when you see something, you have to say, is this malicious or not? It is very hard. Because, for example, here, you don't even know what part of this is folder names and what part of this is parameters. And the rules for safety for folder names and parameters are different. So if you either let through stuff that's malicious or you block stuff that's good. Yeah, that's the problem. And that is the huge problem all through the thing, is that very often the amount of information you have available on one system is not enough to really decide whether what you're doing is safe. You really have to know the whole system, and that's asking a lot. That's why what we really need is several layers of intelligence. We need an intelligent person on one system, and we need an intelligent manager above them looking at the bigger scale. And that's the only way you're going to get there. And right now, that's very difficult. That's asking a lot. And we're all struggling about how to somehow train and prepare those people to do that. So let's get back to web functionality here. So back in the old days, you'd have static web pages. Like this was called Web 1 when Web 2 came out, where you just have pictures and tables and images and text, and people just all view it the same, like broadcast television. They all just see the same thing. It's one way only. You're just looking at something. Now, this is pretty simple, and they didn't have much in the way of secrets on the server, so it wasn't too risky. You could hack a page, but all you could do is deface the page. But then you got dynamic content. This is where people log in, they see their own Facebook, their own email, you remember who they are and show them different products because you look at, they track them and figure out what to sell them. And now your server is running all these scripts that are taking data from the user and customizing the content. And this is so valuable, it's worth doing, even though it's problematic. I remember when I was a kid, they would mail you catalogs, like millions of identical catalogs going to everybody. They should know this is for the birds, this is stupid. They should customize the catalog for each person so it has what you want on it, and that's what we're getting with, like Amazon. It's a much more efficient way to sell things. So you have to send parameters up to the server. You can put them in the query string, in the file path, in cookies, or in the body of the request. Those are all ways they can go up. And the server can interpret that any way it wants. You can write your own software on the server that looks for data in any of those places, in any part of the request. There are no hard and fast rules. It would be a whole lot simpler if there were rules. All parameters have to be in the post, or have to be in URL or something, but there aren't. So you can have user agent, which is sometimes important and sometimes not, although these days it's almost always important because so many people use smartphones, and you really don't want to put the same content on a smartphone that you do on a desktop. Only really sleazy people like my webpage do that, because it's really hard to read on one or the other. And if you're at all serious about your business, you have some kind of smart platform to customize your page so it looks good on a smartphone. So then you got, on the server, you got a bunch of scripts running in all different languages, like VBScript and PHP. You have web application platforms, like ASP and Java. You got all different kinds of web servers. You got databases with their own idiosyncrasies. And you got other things. You've got content management systems like WordPress. You have Magento running up there. You have many, many things running up there. Many program systems all running to try to deliver this content and most efficiently update the content. So Java is a big one. Java is very, very annoying to use. It's very hard to install on platforms. It's very buggy, it's very slow, and it's used by almost everybody because it saves you so much money. It's worth putting up with incredible harassment all the time. And the reason it saves you money is because if you don't use Java, you have to write another version of your app to run on Mac, Windows, and Linux. But if you write it in Java, it runs everywhere all the same, because it runs in a Java virtual machine, which takes bytecode, which is partially compiled stuff, which will run the same on every platform. So you don't have to write your app over and over again for different platforms. And the other thing about it is it's very easy to scale to large clusters. So if you're a big company and you're hitting the big time and you have an important website with a lot of people coming to it, you need a lot of servers, you've got to scale up to Java. And you put up with all this harassment of the difficulty running Java to get the power you need to run big applications. It's like Oracle. Oracle is similar. If you have a simple MySQL database or an Excel spreadsheet or a Access database, that's good enough for small business. But when you're huge and you have millions of customers, you've got to use Oracle. Oracle is big, expensive, complicated, and confusing. You have to get difficult certifications to run it, but it's worth all that. Like Microsoft Active Directory, once you're at a certain scale, you need all that complicated stuff, and you're willing to put up with all the difficulty of running it to get those features. Because if you're like IBM, and then you buy another whole company like Yahoo, and you have your 1 million computers, and you add their 1 million computers and integrate them into your network, you need Microsoft Active Directory for that. There is no other product that can swallow a whole company and somehow efficiently integrate all their stuff into my network. And it's the kind of issue you get with these big, difficult products. So Java has these things. You got Enterprise Java Bean to handle business logic, plain old Java objects and Java servlets at different levels to handle different levels of complicated processing. And they got Java web containers also, and this goes with Apache Tomcat. I've used quite a bit of this running the Wall of Sheep at DEF CON and other things, and I've done it at CTFs and stuff, because that's an enterprise class product that's made by Ares Security, and he's selling it to the US military to train people in packet analysis. And so he wrote it with the enterprise class stuff, so it can scale out to vast numbers of users and locations, whereas many times when I was at the Wall of Sheep at DEF CON running it, it's crashing. I said, I'll just write a little script in Bash to get the job done. Because for my classroom, a little script could do it. But he has it all on this big platform because he's trying to sell it to big customers. So this is the difference between amateur and professional level programming. What's that? Yeah, Apache Tomcat. Tomcat is their Java-based server. And if you just want to serve one web page from one server, it seems like a total waste of time. Just run plain old Apache and everything's fine. Tomcat just seems to make it all baffling and complicated for no reason. But the reason why you put up with it is because it now has the ability to scale out across many servers. Yeah.
What is Docker's, Kubernetes, and like JSON? Where does that fit?
This is a very good question. I know about Docker and Kubernetes. I don't know about JSON. Yeah, I know Java. I've done Docker and Kubernetes, and that is the future. Docker is the replacement for virtual machines. Virtual machines, when I first heard about them, I was amazed. Virtual machines are so inefficient. I have maybe 10 gigabytes of stuff to run, say, Windows or Linux. Then I make another virtual machine. I make another 10 gigabytes of stuff and another 4 gigs of RAM. I run 3 or 4 virtual machines. I've used up all my resources. Now, that's the way virtual machines work. But I said, this really seems stupid, because if I'm running like Apache in one virtual machine and like MySQL in another virtual machine, 90% of the data is identical. It's the server, operating system. That's what containers do. Containers do not make any extra copies of files. So if you have a Linux host and you put a Linux container on it, it just uses the same files with no change. It puts this thing called overlay FS, which is a file system that records whether you have a different version of this file or not. And if you put an Ubuntu Linux container on an Ubuntu Linux host, almost all the files are identical, and it does not make a second copy. So the container is really no bigger than just a folder. And then when you install something in it, like Apache, it puts on those files, but it doesn't make copies of the other files. So you can run hundreds of containers on something that could only run a few virtual machines. It's much lighter, much faster, but it's less secure because it doesn't really isolate them from the host as much. But that turns out to be an extremely good thing. Most people can get much more done from your hardware by running containers than you could from virtual machines. So now the issue is, how do you deploy containers? If I make one server, I put up 50 servers, then my site gets popular. Now I wish I had 1,000 servers. I'd like to have an automatic thing that will spin up more containers. And that's what Kubernetes is. Kubernetes is the orchestration platform where it tells you, run up more containers, deploy more of these, and it works from images and pushes out these images. So, and it's pretty cool. You can run it locally. I got interested a few months ago because Kubernetes had a serious security flaw, which turned out to be less fun than I'd hoped. But we may get there. I'm thinking the red versus blue, I may get down to where you guys are actually deploying Kubernetes and clusters of containers. We'll see if we get there this semester.
It's going to be more of a security challenge.
People have argued about it. In fact, there have only been a few major container hacks. It is very important to get used to containers and orchestration. That is the real future. And of course, it's new. It's all been only in like 3 or 4 years ago it started. So of course, the first versions have flaws. I think I don't know. Some people say it's going to be insecure. Other people say as soon as they clean it up, it'll be just as good. The fact is, it's a whole lot cheaper. So even if it's less secure, that's probably worth putting up with.
So we've been on iOS, because iOS is kind of like that.
Yeah.
We've got a sandbox, we've got containers,
Yeah. You can run it right on iOS. And by the way, there's another huge reason to use containers, the same as virtual machines. If you've done it in my projects, you've already begun to see this. You install some program, then you need to install all the applications, all the libraries it requires. Then it turns out you need an old version of something. Then it turns out, the old version is hard to find. It's only for Red Hat, but you're on Debian. You end up spending hours or days trying to configure it. And this is really a drag, especially as time passes and whatever you want to deploy is something somebody put up like 3 years ago. Now it needs out-of-date versions of everything. And virtual machines are one answer, but they're very annoying. This is why people are now getting over this. Just deploy a container with your thing and all of everything it needs. And then I'll put the container on a host and it will just run. And I will not spend hours trying to resolve all these stupid dependencies. The container is the efficient way to deploy things. Really, the way, if you make a Windows application, you just give me an installer, I double click it, it goes on. The open source people are also saying, why don't you just give me a container with everything I need? So when I run it, it's there. Don't tell me I have to deploy this and this baffling stuff I never heard of and find a particular version. Why am I doing that? Put it all in one box so I can run whatever you've got. That is the way of the future, I think. Anyway, you've got, this is the issue, of course, you've got the part your staff wrote, which is probably very small because you really don't want to waste time with your staff reproducing other people's work. Most of the time, you're going to use libraries that came from other people. And ultimately, this gets extremely unsanitary. You're using libraries that came from a company, they're using open source stuff, and they're using open source stuff until you're actually getting stuff from hundreds of people far away and long ago that you don't really control and you don't know what they did. So you're getting to be an increasing amount of supply chain attacks where it turns out that some library you're using is broken or worse, poisoned. Because now, what I've heard in the last month several times is if you have a popular library function that you wrote or a popular extension for some product like Firefox, criminals will come and offer you money to buy it from you. And then they will put malware in it and it can infect all these people with the next update of it. So, you know, if you think about how many people you're trusting, you install something like an Apache web server or WordPress with a few extensions, it's not just the few people you directly downloaded stuff from, it's all the libraries they used and all the libraries they used until you're actually getting stuff from a large number of people you know nothing about and trusting it. Every one of them could give you a bad version or a bad update. And that is beginning to happen. So it's an issue, just sort of like the US military a few years ago started saying, you know, we don't really trust this hardware we got from China. And we'd like to not have any routers and switches from China. And yet, where can we get them? We don't want any chips from China in any of our stuff. Well, everything's made in China. How do you know they didn't poison it? Well, you don't really know. Well, now we got a problem because we don't manufacture that stuff here anymore because it pollutes the water. We can't afford the consequences of the Superfund sites it creates. And so you've got a problem. How many people are you actually trusting? The answer is a lot of people. Anyway, so you got these open source components all over the place at the presentation layer and at all these different layers. These products are being built in, and Microsoft has their framework. And this is one common solution. If you are a large company, you typically have to have Microsoft Active Directory because they're the only company that will really help you manage thousands of machines across several continents in many different languages and everything. They're a real giant global network. And usually, you don't want to mix open source stuff with Microsoft stuff. Usually the best answer is to have Microsoft's version of everything. It's designed to fit in that network. So you use all this stuff. You use ASP.NET and all this jazz and Microsoft languages like C# and Visual Basic. That will make your life a lot easier if you just stay in the Microsoft world. Typically either go open source, maybe open source everything like Python and PHP, or you go in the Microsoft world and you have the Microsoft version of everything, because then you can control it all and have security policies on your domain controller that will handle it. Anyway, so Visual Studio is the development environment for Microsoft. It has free versions and pay versions. The pay versions go up to $10,000. You can get them free from the college. We pay for Microsoft Academic Alliance, so they have some new name, DreamSpark. So students all get free copies of stuff. And this is their big, heavy environment, like several gigabytes of stuff. And then you can write Microsoft applications in a nice GUI and test them and everything. And this is what all the pros use to write all the Microsoft-oriented stuff. You write your web applications in here, and it goes into ASP.NET and so on. And Microsoft has updated it to stop a lot of the common flaws. This is something Dan Kaminsky recommended. Dan Kaminsky is one of the 3 or 4 most famous people in the world of security, and he's a developer, and he found some really spectacular flaws. Yeah.
Sorry, who's that?
Dan Kaminsky, a very famous guy. And he gave talks at conferences, and people would ask him, you know, why are the developers so stupid? They should learn more security. And Dan said, you know, that's really not practical. Telling developers they have to learn a whole bunch of new stuff. They already got something that's hard to know. What you should do is give them an environment that automatically avoids these flaws. That is the practical way to prevent this stuff, not telling them all they're stupid and they need to learn another textbook or 2 full of stuff. It isn't. And the problem is they've already got a job and it's not easy. And security people say, oh, it'd be easy for you to learn about SQL injection and everything. And the fact is, it's not. They're already doing something hard, and just yelling at them that they're stupid is not helping. This is the fundamental problem with security people, and probably IT people in general, is that they think everyone else is stupid for not knowing their thing. And when you start your conversation with anybody by telling them they're stupid, this usually doesn't go to a good place. But that's the most common flaw in this business, is approaching people with disrespect, like the government or something, and I'm wondering, why are these people so mean at me all the time? When I treat them like dirt and then they treat me like dirt back, I feel abused. So
that's more like a used car salesman, like, you know, I just look at your cars, I'm not buying anything, so I don't need your advice.
Anyway, so there's PHP. PHP is the open source product I use to make web pages. It makes it very easy. WordPress is written in PHP. PHP is famous for making it very easy to program and for being fantastically insecure in practice. I've never seen any site use PHP for more than a year or 2 without getting hacked. You can write one PHP app and it can be secure, but if you actually try to use it for a year or 2 in business, pretty soon you're going to get hacked. I got hacked from using PHP script. The problem is it is very easy to file upload vulnerability. That's the main one. But we'll see some of this. So typically what you do is you either use Windows everything or you use LAMP, which is Linux, Apache, MySQL, and PHP. That is typically what you want. These 4 products running together. And this is easy to use. And PHP itself has problems, and the customs code people write tends to have common mistakes. But there's tons of things. What's that? Oh, sure. But my stuff is there to be hacked. That's why I say, I'm amazed when I read Android apps, they're written the way I write apps, which is a really bad thing because I write apps to get them wrong to make them hackable. And Android seems like that's what they're trying to do. Anyway, so PHPMyAdmin is huge to control your databases. There's a bunch of mail, shopping carts, wikis, and everything all running on PHP because it's so easy to write. It is the easiest way to make active web pages and do this and that. It just tends to lead to problems. And Ruby on Rails is another alternative. This was really hot maybe 6 years ago. I don't hear that much about it now. It seems to have faded somewhat, but for a while everybody thought it was wonderful. I'm sure there's still a ton of it out there, but SQL is huge. Everybody has data, and it turns out that the right answer for almost every situation is stored in a database, and there are really only 2 or 3 big contenders. There's Microsoft SQL for the Microsoft-oriented, there's MySQL for the open source people, and then there's like Oracle for the huge enterprise class stuff, and there's a few others, but those are the main ones. So you store data here, and you send queries up to the server. Queries do things like store more data, retrieve data, update data, delete data, if that's how you handle it. And I'll do SQL injection a little later tonight. We'll go through that one because that's really important to understand. SQL injection was for a long time the #1 security problem on the entire internet. Until about 2 years ago, more than 90% of all stolen data was stolen with SQL injection. Although I have not seen an official survey, but my impression is in the last year it has changed, and now it's all stolen with Amazon web buckets, which are wide open. That's an incredible number of them have appeared. That seems to be, what's that?
How about migration? Like if one person says, oh, I don't like this open source anymore, SQL, I want to migrate it to Microsoft. Is that a pain in the butt?
I never hear of anybody doing that. I guess it must happen, but I've never heard of it. People seem to stick with one or the other. But anyway, so then there's XML. XML is just a way to encode data to store it where you make it look like HTML. So you pet, ginger, slice pet, you have open source and closed source. Closed tags for everything. Then you have pets. Here's dog and here's cat. It just looks like it's a way of organizing data. You can store anything this way. You can send anything over the network this way. And it's all plain text. This is Microsoft switched to this. Microsoft used to have proprietary formats for their Microsoft Office. In 2000 and 2003, they had this special binary format for documents and spreadsheets and everything. And in 2008, they finally wised up and said, everybody is mad at us for doing this. We're just going to make it XML. This is like the best way to store data because if you get sued 10 years from now and you have to go and say, find all the documents on your server and on all your backups that have the name of this company in it because we have to submit all our documents in our dealings with this company. If you store data this way, it's easy to search. There's plain text labels. If you store it in some goofy binary format, some of it's WordPerfect, some of it's Excel, then it's really a drag when you have to go find all the data with a keyword in it. It turns out to be actually extremely expensive to cope with that. And since every large company just gets sued all the time, so it's just part of regular business, it turns out to be worth it to just store everything in an easily searchable way. And Microsoft has caught on, and a lot of people have caught on, and just whatever you're storing, store it in XML. And then you'll be glad you did that as the real consequences of storing business data hit you in a few years. Yeah?
So, shouldn't they use whatever PDF has?
Word, Microsoft Word is very standard, but it's XML. PDFs are unfortunately also standard and lead to a ton of problems. And as far as I know, very few people actually store editing things in PDFs. The main point of PDF is just to print it.
I thought you don't change it.
You can, but it's expensive and it does lead to all these other problems. There are only some people do that. I think like advertising departments and stuff.
Because in Word, you can't store things in PDF, right?
You can. You can store it in PDF, but then you don't edit it from the PDF form.
Yeah, that's
I know.
No one gets to change it.
Yeah. Anyway, the PDF is important out there. It never seems to go away. I know I had to switch to printing all my handouts in PDF form. If I store something in Word, you open a different version of Word, it doesn't print right. But PDF is very problematic, but it does seem to be the only format that actually works for printing anything that will look right. It has tons of security problems, tons of performance problems. People keep saying, why isn't there a better choice? That's a good question, but there still is no better choice. We all have to put everything in PDF if you want people to be able to actually see it and have it look the way it should. So then you got SOAP. SOAP is used with HTTP and XML together. So you send a post request up to the server, and in the data, you just put XML. So it's a very simple thing. This is not that different than, say, HTTP, where you get HTML going around. You just a way to send arbitrary data to a server and get arbitrary data back from a server. But this is commonly used for like applications on a phone, where I'm going to send something and get a little bit of data back. So a SOAP response would look like this. It just tells you I'm sending you XML, and down here you have XML formatted data. You can send any kind of data this way, and you'll see a lot of this stuff go by. As I mentioned last time, there are many competing ways of doing exactly the same thing. You can have unstructured data in a post request, and in a response, you can have XML, you can have JSON, and it's all just another way to move a bunch of data both ways. But it means that you can't make any assumptions about what you see. You will see many different forms of the same data flying around. So that's SOAP. Now, if you take data from the user, you could have special characters. In XML, it's less than and greater than signs. If I was able to put a less than or greater than sign in things like my username or my product number, then I could confuse the parser at the next step up and cause it to misunderstand the request. And that'll turn out to be like SQL injection. We'll see this. The server uses web service description language, typically to describe what it has. And so I got some cahoots about that stuff. Let me bring them up. And good, I see it's 6:30. We're moving along just fine. And I should turn up my sound for the glorious Kahoot music. And should be here. This is 129S, 3C, I think. 3D, 3C, there it is, good, okay. And everything is properly randomized. Okay. And I gotta get a place to write the answers, or write the winners, I mean. Well, WITB has won a few times, and we were unable to figure out who they were today. I thought that was close to real name, but that doesn't seem to be close enough to real name. So if you want to get your points, you'll have to tell me who you are. There are some people that don't care about points, but in case you do, you should be aware you'll not be getting your points for the Kahoots.
Then he or she doesn't want to win.
Well, it might not be, but I thought that was like initials or something, but we were unable to figure it out. So I think I saw it last semester. I think at one point I knew who that was, but somehow I no longer know. People that use fake names take this chance. Anyway. All right, I'll wait a few more seconds. Looks like that's it. Okay. What are POJOs? Holy crap. I think I can do it by process of elimination. Oh yeah, I'm remembering it now. It's Java. That is some kind of Java object. Something or other Java object. I remember that was, there's a bunch of Java things and I hate them all, so I sort of remember them by the feeling of disgust they created me, but they are the answer if you're big and important. Anyway, so that is some kind of Java object. What language do you use on a LAMP server?
I love these names.
Yeah. That's PHP. That's the LAMP. By the way, if you are a real pervert, you can use WAMP or XAMPP and run this stuff on Windows. And I don't know why you would do that to yourself, but there are ways to put LAMP stacks on Windows, and then you've created a monster like Frankenstein, which is very annoying. But anyway, they often have fun vulnerabilities, and they're kind of fun to hack. A lot of people really do that. They put a LAMP stack on Windows at one of these products. And then you have weird folders on your Windows that are like Linux folders and stuff. It's kind of strange. But anyway, what system looks like that? That's good old XML, extensible markup language. All right, what's WSDL? Okay, that's SOAP, wireless or web service description languages. You'll see a bunch of these. We'll come across quite a few of them. Another one we're going to have fun with is SAML, Security Assertion Markup Language. These are all XML-based formats to specify information from one server to another, and they often have entertaining vulnerabilities. So I've got WITV1 again, and I got Caitlin, and A.G. Levy. Looks kind of like a real name. You can probably figure out who that is. All right, so we got time to carry on here. And so let's talk about the client-side functionality. This is actually an interesting thing. There was one long ago, back in the days of like MS-DOS, you would actually run something and you could say what computer was doing it. But if you do something like go to Google and type a search and get an answer, and someone asks you what computer did that, there is no simple answer. Your computer displayed the graphics. Google's search cluster of thousands of computers did the search. Routers and switches and proxy servers processed that data. The fact is, a bunch of computers did parts of the work to make that page appear, and it is not true anymore that there is one computer doing the job, not even close. So if I make a web application and it's serving up stuff on the web, it is not true that I control all the processing. A lot of it is done on your computer in the browser, and a lot of developers don't really understand this or even know what part of the processing is being done in the browser and what part is being done on the server. But of course, from a security point of view, it makes an incredibly large difference because I can control whatever happens on my machine, and the developer cannot trust that any of that really happens correctly, but they can only trust what's happening on their server. So anyway, HTML comes down from the web server. In markup, it says, please make this big, please put a picture over here, please play a video over here, and then my browser does whatever it wants with that. I might have ad blocking, things turned off, some goofy browser that doesn't support some features, and the server doesn't really know what experience I have exactly, but they get the HTML coming down. They give me hyperlinks with Ahref that will go places, and then when I click that, it will send a request back to the server. They have forms to give me things to fill out and send names and passwords up, which is common things. So they give me the HTML, my browser renders it. Then when I run this, it sends some data back to the server. And then I send a request. When I send a request to the server, it will put all this information in the request in long plain text. It's got a cookies and referrer and user agent, and it's got specified the name of the file. This is a PHP file. Then it's got a name and password there up in the URL where you aren't supposed to put it, and the name of the host. And it sends all that junk up to the server. You can send different kinds of data. There's a multi-part form data you can send up to send large amounts of data, and then your browser will create long strings of random boundary text like this. WebKit, form boundary, JDG, another one. It creates this long string and uses it to break up the data. That's an official way to transmit data over HTTP. Then you got cascading style sheets. There was a huge movement about 15 years ago to try to separate content from form on the web, because the idea was you would have smart tablets and phones and portable devices that just want the facts, and they want to reformat it to look differently. So you'll have one source of content and a totally different source of appearance. so you can subscribe to the content but ignore the appearance. That was the idea. And they tried to make everyone go to XHTML and CSS. So the CSS would specify the appearance, and the XHTML would be just the facts. They pushed this real hard. It was so like so many other things. Like there have been a whole series of these. Like we're supposed to quit using ifconfig. Every 5 or 10 years, a bunch of academics say, we've changed the rules. Everyone has to quit doing it the way they're used to and do it this other way, and like IP version 6. And the world says, yeah, John, how about we just tell you to get lost and we'll just keep doing what we've been doing and it'll be fine. So nobody cared. This didn't really happen. Cascading style sheets is kind of handy to decorate your page, but it's never became true that form and appearance are separated. Not at all. Yeah.
How do you hack that?
Oh, the CSS itself is just describing how things look, and in itself, it's not very vulnerable, I think. Neither is HTML really. The only part I haven't heard of it commands inside CSS. I guess in principle you could, but I don't think so because it doesn't really have any active content. But JavaScript, now there's a programming language. See, HTML is not a programming language, and neither is CSS. You can't even have a number and add one to a number or have an if statement or anything. So if you actually want to have any logic to calculate something, you need a programming language. Now, originally, JavaScript was the main one used, but for some reason, the early implementations of JavaScript were programmed incredibly badly in browsers. So for decades, people used JavaScript just to pop up a box or something, and that's all it was good for. But about 10 years ago, Firefox and Chrome decided to rewrite the JavaScript processing engine and make it 100 times faster because it turned out that it was slow for no good reason at all. And suddenly, JavaScript became the most efficient way to do everything. That's when we got Angular and Node.js and all this stuff to where it's awesome. And they shamed Microsoft. After about 5 years, Microsoft finally had to join the bandwagon and speed up their JavaScript engine. And now Microsoft is abandoning their processing engine and just going to use the same thing everybody uses, WebKit. So everybody's going to be using the same way to interpret pages. So JavaScript is now the new hotness. I think VBScript was Microsoft's attempt to have an alternative to JavaScript that should have their brand name on it. Nobody ever cared. It pretty much came and went. It's still technically around. It's an entertaining vulnerability. You can put VBScript on pages and run them on Microsoft machines because people have forgotten it exists, like floppy drives, but it's no longer used for any actual valuable purpose as far as I know. So a document object model works like this. You have a document, and then you've got an HTML element, then you've got each element on your page, like titles and forms and everything, all can be referred to. So you can refer to an object, you can write to that one object, you can read the contents of that object, you can create another object connected to it. That's called the document object model, where your page is a structured, tree-structured, layered object. You can refer to every object. That's how JavaScript works. So you can make a page, it'll do document, get element by ID, demo, inner HTML equal hello world. So I have hello world down here, but I did not put hello world directly in the text. There's nothing in here, but up here there's a paragraph called ID equals demo that just closes and doesn't have any data. And this JavaScript finds it and then puts content in it. And this is how you can make content that's calculated and changes. And we're going to have a lot of fun doing injections this way. This is how you do DOM-based cross-site scripting. And it turns out to be a very common flaw on the web, that people do, in fact, put content in this way, and they forget that you can put malicious characters in that content. And then there's Ajax came out. This was how Google Maps was the first big application of this. You can have Google Maps, and you can kick the mouse and drag the map to the left, and it very quickly moves everything. It does not, like the old days, if you drag the map an inch to the left, it would have to erase everything and load a fresh map from the server, moved 1 inch to the left, and that would take forever. But Ajax can actually keep all the part you have and just load the 1/4 inch I need and put that in, and the next 1/4 inch and just fill it in as I drag to the left. Because you ask for not a whole page, you ask for, I want just a little bit of the page. I want just a little bit, just a little corner here, just this little edge here, and it can give you just that much so you can keep up with motions. This turned out to be very cool, Ajax.
What year was that?
Oh, I think it became really popular about 10 or 12 years ago. And it never stopped being popular. A lot of the web really runs on Ajax now. And you have this special thing called XML HTTP request, which requests something other than a whole page. I want just this little chunk of a page. That's the idea. Instead of giving me an extra copy of a giant thing where I already have most of it, give me just a little piece I want, which is very logical. And so you've seen this. And if you drag this down and look in Wireshark, you'll see all these requests going by to the server. Get and it tells it, give me just these coordinates. And it gives it just a little bit of the page while you drag it around. A lot of little requests instead of one big request to redraw the whole page, which is the only way you could have done this in the old HTTP world. Then there's JSON. I mentioned before, JSON is where you ask for data and you get it in JavaScript notation. So it's defined the way JavaScript variables are. So it has these curly braces, and then it has name colon value for name value pairs. This is the same kind of data you could very well have had in XML. This is just another way to do it. And this is the natural way to get it if what you're going to do is process it like JavaScript at this end. And as I say, JavaScript is very, very popular these days. Turns out so many whole web processing frameworks are based on JavaScript that you often want everything in JavaScript format. Just like if you're a Microsoft shop, you want to use all Microsoft applications everywhere, Microsoft messaging, Microsoft email, because it'll work better with all your other stuff you're using. So you can update data with JSON. I can send a post up to the server, and down here I put the information going up to the server. Now, I mentioned before, all security on the web is based on the same origin policy, which is extremely fragile and buggy, but this is what everything about the web relies on knowing where you are. So if I'm on the City College domain, I'll send it to City College cookies. But if I'm on the Yahoo domain, I'll send it to Yahoo cookies. So the browser has to know where you are. And turns out there are 100 ways to fool your browser into not being correct about where you are. But all the security relies on this same origin policy because your browser has a bunch of secrets, essentially. It should only go to one company. But it turns out, of course, that your browser can be confused, and even worse, if you think about a company like Facebook, Facebook's as becoming incredibly open now. Facebook's entire model is to collect all your data and sell it to other people. So in fact, giving it to Facebook doesn't mean you're giving it to only one company. They're giving it to everybody and their brother, and they're often doing it in an automated way without even knowing it by letting someone else put an ad on the page. So, you know, it's very unsanitary and leaky at your end and at the other end. When you say, I'm giving this to Google and nobody else, that's not really true at this end, and it's not really true at that end either. Both ends are kind of leaking it all over the place. And that turns out to be a lot of problems. It leads to these things like cross-site scripting, cross-site request forgery, and a bunch of other attacks we're going to play with, where you trick it into misunderstanding the context of a page. So you have a page making a request to another domain, and so you can have a script that's supposed to run on one domain, but somehow you confuse the server or the browser into running that script on the other domain. So now I can steal a cookie that I wasn't supposed to have access to, things like that. HTML5 was a big update, but the only thing it really did was kind of get rid of Flash. Now, Flash was a disaster from a security point of view, like PDF. It made pages look beautiful, so everybody used it, and it turned out to be all full of flaws, to where you kept on taking over machines through it, like client-side Java. Flash and client-side Java have pretty much gone away, thank God. They were just wide open doors to take over machines. HTML5 is the update. You can actually run videos without Flash and plugins. It seems to be pretty good at that. There's a way to play active content without having to have a special plugin to handle it. This seems to be, I haven't heard of a lot of security problems. This seems to be, from a security point of view, a considerable improvement. And I think for a lot of reasons, and really we have Steve Jobs to thank for that. The only reason I think Flash ever died is because Steve Jobs said, I'm not putting this garbage on the iPhone. I don't care how much you love it. My iPhone viewers are not going to see this crap because it'll totally mess up the phone. It's just going to make it vulnerable, drain the battery, look like dirt. I will have nothing to do with it. And he was so big, he was able to do that. He's also the reason we have legal music. Before iTunes, the only way to get music was BitTorrent. It was illegal, but there was no legal way to get it. And Steve Jobs is the guy that said, I will sell music to my vast number of Apple users who will really pay for it, but you have to do it my way with iTunes. And he could actually shove record companies around. Now, when Google went to China in 2010 and totally got ripped off and lied to and stolen in China and came home, they said, we're going to come home and China will change their ways to please us. No, they did not succeed in shoving China around. If you think you're big enough to shove China around, you got another thing coming. But Apple was big enough to shove the record companies around. That's doable, but you know, this happens occasionally, that one giant elephant can actually shove the other one over. Anyway, so Web 2.0 is this heavy use of Ajax and other technologies where everything is, we're using all these to make dynamic, beautiful web pages that respond to the user, and you can have all these fun things we have now. But a lot of them use browser extensions like Java and Flash, Silverlight. Boy, I don't know if you remember this. Microsoft's attempt to imitate Flash that went away. Even Microsoft doesn't support it anymore. ActiveX was another early Microsoft competitor with other these things that turned out to be a disaster and is also pretty much gone. But anyway, a lot of these are the extensions. Everybody had a bunch of these extensions in your browser. Now you don't need them so much. HTML5 has pretty much replaced these. Anyway, you have stateless HTTP. The fundamental protocol you're using to talk to the web does not remember who you are. HTTP is one request, one answer, the job is done. All these other techniques are patches added onto that to remember who you are with sort of ad hoc controls at both ends. So you create a session on the server, which is not part of the HTTP protocol, and it now has some kind of database and some kind of memory control, remembering who you are and which shopping cart you're loading and which email account to show you. And this is, data is flying back and forth. And another very common problem with the web is that the session is not actually maintained on the server. The developer passes the session down to you in a cookie, and then you pass it on to the next server in the form of a cookie, and they now trust it to still be the same session. Like I said, this is a fundamental same problem I made before. They pass something through the client and then trust it after that. Whereas in fact, the client could have done something evil, and the developers often don't think of that because they're maintaining one server and there's another team of developers in another building maintaining the other server. And they really don't have any way to move the server-side state from here to there, so they just bounce it off the client, and it seems to work fine, but it leads to vulnerabilities. So often you have encoding schemes to encode the data that went to the client, both to make it more deliverable and to make it harder for the client to mess with it. So URL encoding is the simplest. If you want to move special characters like plus signs and spaces, you just use these ASCII codes, 0x20s for space and so on. That's just an easy way to move characters around, which is fine. So 25 is percent and so on. All right. You can URL encode these things. Then there's Unicode encoding, because not everybody uses English. They use Chinese and Japanese and Arabic and everything. So we have Unicode, we have 2 or even 3 or even 4 bytes for a character for languages with a lot of characters like Chinese. And so there are Unicode encodings for characters. So you can often sneak through characters that the security people think they are filtering out by encoding them with these other systems so that they don't realize that you just snuck through the forbidden character. There's UTF-8 encoding, which is the variable length where you can have many, many bytes to encode funny things like copyright and not equal and all that jazz. And you got HTML encoding, where you use this ampersand QUOT semicolon for a quote and so on. Another way to represent these characters. And so if you wanted to say, I want to stop SQL injection, so I want to remove the apostrophes, how hard could that be? It turns out to be pretty hard to find all the different encodings of apostrophe that are flying by and block them all. You can also do this kind of thing. You can use HTML encoding using the hexadecimal number instead of the alphabetic version, and on it goes. Then there's base 64 encoding, which totally works on the web. You use 64 characters, uppercase, lowercase letters, the numbers, and then 2 more characters like plus and slash. You can take anything, turn it into binary, and take the bits, 6 bits at a time instead of 8, and turn it into this mess, and it'll work. You can take IP addresses and put them in base 64 and put them in your browser and open pages. This is understood at both ends, but again, it means that when you're trying to find the apostrophe, it might have some of the bits in this character and some of the bits in that character. Of the 8 bits used to encode that apostrophe, actually finding it is a pretty heroic job now. This is why the general philosophy of finding bad stuff is kind of a loser. Blacklisting in general is kind of a failed policy. That's trying to enumerate all the evil in the world, and it turns out there are so many ways to disguise the evil that it is very, very hopeless to try to stop all the evil. It's a whole lot more effective to do whitelisting, where you only accept things that you recognize as good. That way you just enumerate all the good stuff, and that is more achievable than enumerating all the bad stuff. Anyway, then there's hex encoding. If you have A, B, C, you can just put 41, 42, 43. Those are the hexadecimal numbers for it. That's also used extensively. And then there is this thing called serialization, which is hilarious for being a fountain of endless insecurity. You have ways to take blobs of data and encode it in a blob of data that comes down to the server text, and it's hard to modify. So Java serialized objects are one of the most common ones, but there are many ways to take chunks of data and stick it in a blob. And some of these are actually pretty strong. Like there are versions of Java serialized objects that are actually signed with a digital signature. It's hard to forge, so you can tell if they've been modified. But a lot of people don't turn that on. So anyway, in general, I came across this just today, a illustrative explanation of client-side encoding. So I thought this was good. And it's on 129S. It should be right at the bottom. There we are, client-side validation. Here, this illustrative diagram demonstrates the joy of client-side validation. That's the point. This is what happens when you have a security measure that's implemented on the client side, right? They control the client side. How do you know that they went through your test? They can just turn off your test. And this happens over and over and over. And it's easy to get a bad attitude about security and say everyone involved must be an idiot, but it's not that simple. They're smart in a certain way, but there's something they didn't know that was important. So they end up looking ridiculous. When you like just turn off JavaScript in your browser, and now all their JavaScript validation doesn't work, and I send up poison stuff, and they say, wait, that's impossible. I prevented that. I said, well, you didn't prevent it because that code was running in my browser. Yeah.
More complicated is the password, both sides.
Well, passwords are not the main issue here. The main issue here is active code like scripting. And for example, you might want to take from me a username and a password, and you might want to be sure that I did not put any script in that password. So you might want to remove all less than signs, greater than signs, and apostrophes from that password. And that, I say, can turn, and the simplest way is write JavaScript that does it on the web page, but I can turn that off. So what you really have to do is, on the server, clean all that stuff off, and you have to actually consider all the ways I could have hidden it. That's why it turns out to be far more difficult than you think. The general solution is you should clean things up on the output side. When you're done processing and you're sending the data out, that's when you should check it to make sure it contains only good stuff. That is the safest way to do it. Trying to identify the bad stuff on the way in and remove it is always going to be leaky. So making sure that whatever the end result is good is considered the best policy. And that's why I say whitelisting usually beats blacklisting. Take whatever the final result is and make sure it is acceptable. And that's a general philosophy. Anyway, I got another set of cahoots here, and then I just want to talk about the SQL injection project. So this is 3D, which is here. Okay.
That video would have been more funny if they added a fingerprint. Yes, very good.
Oh, sure. Yeah, no end of it. All right. It's actually warm enough in here, which it has not been anywhere all day.
Yeah, you need 2 layers of pan. I like it.
You need 2 layers of everything. Although I can't complain too much. My sister sent me the weather report a couple days ago. It was like minus 45 degrees in Milwaukee. No, the temperature map. She said, having a great time. Wish you were here. Yeah.
If she's shoveling snow, that would be more.
I don't think anybody's shoveling snow. I think they're all hiding in their house, waiting for it to stop, which I think it did stop. But it was pretty ridiculous. Anyway, wait a few more seconds to see if we have any more. Still coming in? Okay, good. Wow.
Yeah.
Oh, wait.
This is a cage.
Well, but we have those devices, which are emitting powerful CCSF Wi-Fi. Aha, I see you made it in. Okay. I'll wait a few more seconds to see if we got any more. You coming in? Okay.
Sorry, I got called over late at work.
I know
A
how.
bunch of people called off because, they're sick or hungover from the Super Bowl party.
Oh, yeah. Well, I know that happened. Still coming? Okay. Well, we got plenty of time.
Yeah, what's 5G going to be?
5G? Oh, I don't
Cell
know.
phone network.
I've heard about it. I don't know when it's coming.
I don't
Probably.
think security was the key.
Speed was all they cared
Is
about.
that you?
Speed.
You didn't? Okay. All right. All right. Well, let's go. I think we got enough. Okay. So, all right. What system defines formats like that? Font weight, bold. Well, none of them put up with typos really. Oh, that's one of the huge issues of computer work. Is people make typos and they turn out having weird results. That's cascading style sheets, what that junk is. Which one of these is obsolete? Boy, there might be more than one. Let's see. Well, there's definitely one that is by far the standout. I got to watch it with questions like that because the answers change from one semester to the next. Okay, VBScript is the most obsolete on that list. All right, if I request data from the server without refreshing the whole page, what technology will do that? Okay, that's Ajax. And what system writes a space like that? That's HTML encoding. That's one of the forms of spaces. All right. So let's see. I got Caitlin and WITB and M. Ojo. We found out who that is. That works. Okay. All right. So I got my winners. And I just want to talk about the SQL injection because it's real important and it does require some explanation. So let me get rid of this and let's go here. All right. So here we are, 129S. And you've got SQL injection here and more SQL injection down there. I just want to go through a few of these. So this is SQL. So you go here, and this is a common tutorial people have. So I reset the database first, which, by the way, the reset is not perfect. There's some extra stuff people have hacked in the database here that never gets cleaned up. But anyway, it's usable. So this is the way databases work. Most people use Excel at companies far longer than they should because they cannot understand databases. Excel is just one table with columns and rows like this. And that's fine for very simple cases, like you have a price list. I have products and prices. But if I do business and I sell things, then I have customers and transactions. And those are related in a non-one-to-one way to each other. One customer might buy several things, then they might return one thing, then they might buy more things, then they might owe me money. And I might collect money but not get all of it. And then they owe me more money. And that kind of stuff doesn't fit in one table. You need a database for that. So you have users here with username and then whether they're an administrator, and then you got social security numbers stored over here. Now in this case, you don't really need a database for this because you're only going to have one social security number for every user. So this could all be in one table, but this is the way this one is set up just to show how it works. In practice, the reason you use a database is because you don't have SSNs here, you have transactions. And so there are many records corresponding to each one of these, and you keep having more and more transactions and not adding more users all the time. So you need the ability to have a one-to-many connection. But in this case, there's a one-to-one connection because we're just trying to create a simple situation to see the vulnerabilities. So this is how you actually control a database. And this is something you would never expose to the end user. This is what the developer really uses, is select queries. So if you select star, that's all the data from the name of the database and the name of the table. So the database is SQLOL and the table is users, and that will give me the first table here. So if I run that, I get all the data in that table. Now if I go back and I take it from, say, SSN here, then I get all the SSNs. This is why you don't expose this kind of interface to the end user, because I can see things that I shouldn't be exposing to everybody. All you should be seeing is your profile with your data, not other people's stuff, so you don't let end users put in raw SQL commands. But you can do lots of things here, and a couple of these are worth doing, like you can select everything from the SSN where the name equals something. And you put the name in quotes, so I can do this. And this is how you specify one person. And this is what the scripting would actually do when you look at your profile on something like Facebook or Google. It takes your identifier and gets the data just for you, so you see your profile data and nobody else's. That's what should be happening, but it should not be under your control. It should be under the developer's control, so you don't have any way to see anybody else's stuff. All you can see is your own stuff. So now you can actually add two things together. So now if you try to go for a name that's not there, let's start with this one. So if I go for Fred, but there is no Fred, so where name equals Fred, but there is no Fred, I get 0 results. It's not an error. It does not produce an error message. It is a valid question, and the answer is no. There's nobody there. You get 0 results. That's perfectly fine. But now, I could do this. And this is, we're getting closer to what we're going to do to steal all the data here. You can have a combination condition where the condition is name equals Fred or A equals A. This is a general logical condition in all programming languages. You can have this condition or that one. So name equals Fred is never true, but A equals A is always true. So false or true equals true. So this condition is always true, and I get all the data. This is what we're going to use to steal data from databases. And the answer is pretty simple. So there's more things you can do here, but I'm just going to go down to the username. This is more like what you have. You have something like a login page where you can put in your username and password and nothing else. You cannot put in select or anything. You just put in the username. So if I put in a real username, like herpderper, and submit, it finds that name herpderper. This is what you do when you go to your profile page on something like Facebook. So if I try a name with an apostrophe in it, like Mike O'Neill, then I get this error. Now, this is something you should never see, an error in your SQL syntax. Now, you can have errors like letter found where I expected a number, and that is kind of unprofessional to show that to the end user, but it's not an important security flaw. But if I can break the syntax on the server, that means I no longer understand whether what I'm looking at is data or a command. That is very, very dangerous. I should not be able to break the syntax on the server. If I can, you have lost control of your application. And the reason why this happened, I put the query here so you can see it. This is executing that query. And the problem is, select username from users where username like Mike O. All right, up to here, it makes sense. But that apostrophe I put in was matched with this apostrophe the developer put in. And so now it expects Neil to be a command like and or. So part of my name is interpreted as a command on the server. So I can now run code on your server when I was just supposed to be able to put in data. That is really fatal. And this is from a fundamental, extremely stupid situation, which is I wrote the form. The form collects data from the user. I pass it on to the server. The server now tries to parse that form and match special characters like apostrophes to guess where the data is when I knew where the data was. But I didn't tell the server where the data was. I gave it a string as if a human had typed it, and now it has to guess and hunt for where the data is. That's the fundamental problem. And this is the fundamental problem with all web apps, is you have a server that knows what it's doing, and you pass a very incomplete request to another server that doesn't really contain enough information for that server to correctly understand what you want, and it misunderstands it. And this is going to happen through the whole course. So this is how you find the vulnerability, and then you know you own this thing. So now you can find things. And so I can now ask for anything. Now I can put active code on the server. The problem is, in SQL, you have to ask for things by name. So I could have a list of every possible name or try every possible combination of letters and get in. But the easier thing to do is to go for the objects that have default names. There are only 3 or 4 popular databases in the world. If it's open source, it's probably MySQL. Otherwise, it's Oracle or MS SQL. And they all have tables that they create that have default names. So since this is MySQL, I can use this table schema from informationschema.tables. That is the database created by this MySQL software that always has the same name. So if I put in this query, then I have this strange result. It is not an error, and instead of getting usernames, I get database names. And the reason I do is because I put in this username as if this was a human name all the way to there. And that username carefully contained a bunch of apostrophes. And I had to put an even number of apostrophes in here so that it would not create an error. And so it matches, it misunderstands it the server by thinking I'm looking for a username that is nothing, and adding a second query which looks for table schema as username from information schema tables. And now for A equals A, the only point of this clause is to use up the extra apostrophe. So that now I can take this up, the developer putting these two apostrophes outside the colored region, and I had to make it so that whatever I injected would fit in there without breaking the syntax and stay valid. But the result is I can now get whatever I want from any table I want when they thought I was just searching for a user. So now I have the names of the databases. After you've got the names of the databases, you can then go for the names of the tables. And that's what this does. So that one, the tables are SSN users, and the reason that works is because I fed in this whole mess as the username, but the server misunderstood it as username like nothing, union, select table name as username from information schema tables where table schema equals SQLOL. And again, I had to carefully write something to use up that last apostrophe. So now I have the name of the tables, and now the last one steals all the data. Well, this gives me the columns in the SSN table. If I didn't know the column names, then I can get them this way. And again, I fed in that for a username. And it didn't work because I have an extra space at the end. So it looked for the name SQLOL space. And there is no table named SQLOL space. So I have to go back here. This happens to students doing it too, and get rid of that space. Otherwise it won't work. Now, there's the username I fed in. And it found column names from information schema column where table name is SSN and table schema, which is the database name, is SQLOL. So these are the columns in the SSN table. And now that I know the database, the table, and the column names, I can ask for what I want. And that's what this last one does. This dumps out all the secrets. And so there it is. This gives me a table of usernames and passwords. This is how they stole, not I say, until about 2 years ago, this is how like 95% of all stolen data was stolen. You don't need anything but a browser. All you need to do is copy and paste a few things or run an automatic tool like Dafydd that just automatically does this. And it turns out 11% of the web is vulnerable to this attack. It is very, very common that people make this mistake. They write their SQL code in this way, and I can just take a field that took in something like comments or names and addresses, usernames, phone numbers, and I can just put in these goofy looking things that contain a few apostrophes, and out comes all the data I was not supposed to be able to see. It's extremely powerful. And you're going to see it come back over and over and over again. And this is the general problem with the whole web, is that I can somehow send up something that looks okay to this server, but has some catastrophic effect on the next server. And what's happening here is the HTML server is passing it to PHP. The PHP script is taking the username, looks fine, putting in the query, and then passing it on to the MySQL database, which gets a request. But I did not tell the database what part of this was data. I just gave it a long string for it to figure it out. I could have written a better kind of query that would have told the SQL server what to make of this, and that would prevent this. So this one here is one kind of defense where I have input validation. If I put Mike O'Neill in here and submit it, I just get no results. There's nobody named Mike O'Neill because this one filters out the apostrophes. And that's enough to stop this particular attack. It doesn't stop all forms of SQL injection, but it will stop this attack with this one thing, MySQL real escape string. That will just escape special characters. They'll put a backslash in front of the apostrophes so they aren't treated as a meta character. That's enough to stop most simple SQL injection attacks. There are some that don't use apostrophes when you're going into numeric fields, and this won't save you in that case. And there is a better solution, which I think I don't have here. But the better solution is parameterized queries. Yeah, here we are. This is the one I want to show you. Fixing it with parameterized queries is here. There. This is what you do That's the safer code with parameterized queries. It takes about 6 lines of code instead of 1. This is how you create a different kind of connection to the database, a PDO connection, and then you define something where username like :username, and then you define this :username thing as a data object. So you pass the username to the server, not in a long string of text with apostrophes, but as a data object called uname. And now the server understands this is a username, this is not active code, and there's no way to do SQL injection anymore. This is what everybody should be doing, but the textbooks don't tell you this, and the classes don't tell you this, and the developers don't know this, and every time you patch a database, some new person comes out of college and makes another database vulnerable again. So this was discovered 15 years ago by Rainforest Puppy, who worked at Blue Box Security in San Francisco, that works there now, and it was awesome, and at that point, 11% of the web is vulnerable, so we told everybody and had a huge education campaign, and now only 11% of the web is vulnerable. We're getting nowhere. This is true of almost all security problems, and I found it very frustrating when I was new to the business, but you ought to compare it to other problems, like how a bunch of people die of cancer because they're smoking. And people keep on smoking, people don't get exercise, people drive their car too fast, people drive drunk. A lot of the problems in the world are from people just being idiots and doing something that they know they shouldn't be doing. And this is no different than that. You know, it can be frustrating, but it really is not that web security is stupider than the rest of human life. There's a lot of things going on that are just stupid and wrong, and they stay that way because it's a little too much bother to fix it. So anyway, well, it's job security for us. This is why everybody has to hire a security team to notice what stupid things are our developers doing and what will we do about it. And that's the way it is. Anyway, so that's the one you have to work through, and there's some challenges here where you get to do various things with your SQL injection. And you should try it and get used to it. It's big, and we'll be doing other similar attacks later in the class. So any questions about anything? Well, I'll stop the share. I'll go upstairs and help anybody who wants to work here. And I'll see you. Oh, there's a chat message. Maybe somebody told me who they are. Could you inject SQL through cookies? Yes. In principle, you can. You can inject it through anything that leaves fields in. So sometimes it's cookies, sometimes user agents. Yes. If it is processed by SQL at the other end, you can feed the data in. Yeah.
So other SQL databases I found that recently can actually access raw machine code that is custom made. So I ran into a SQL server that was running as root. So in order to get full control over the system, I had it write a file into its own library directory.
Yeah.
And my own, code.
Yes.
You can do a ton of stuff with the SQL injection, not just get, data that you're not supposed to.
Oh yes. In fact, I'm glad you mentioned that. I really should demonstrate the PHP shell. I shouldn't skip that because that one's not obvious. And I learned this from attackers. I put up this page about 6 years ago, and I had a certain project. Put your name here, put your name there, and some guy changed everything. Put a background picture in, and I said, "How did you do that?" He said, "You're so smart, figure it out." And I said, "Well, crap." So I went and looked in the logs, there was nothing. So I turned on a bunch of logging and changed some permissions. He said, "There, you can't get in this one." So he got in that one. I said, "Damn it, what did you do?" He said, "You're so smart, figure it out." So I had to go, I had to do Apache forensic logging. I learned about this, where it recorded every complete request. And then I found out what he was doing, which was bloody awesome. And here's what he was doing. You can write to a file from SQL, which I did not know at this time. So you can not only search for data in a database, you can write to a file. The only trick though is you can't create a new file. I mean, you can only create a new file. You cannot alter an existing file. So I'm gonna write test 221. I think that's a name nobody has done. So this is gonna write this text into that file, test221.html. Now I can do it. And when I do it, I don't get an error message. Now there are no results, but it didn't crash. So it did create that file. Now it's a little hard to find that file. Temp test221. Normally the temp folder is not visible, but I made it visible on my server just so we could do this project. So it's attack.samsclass.info /temp. There it is. Okay, so now I can write to a file and I can see the results of a file. So this is the kind of thing scripts kiddies do, put an insult up there, and now I can brag that I hacked you. But I can do much more. And the reason I can do much more is yet another horrible thing. It turns out that on the web, it is very common to mix multiple languages in the same file. Now, this is completely insane. And I remember 20 years ago, everyone screaming and yelling at Microsoft. They said, you rotten bums, you took Word documents and you put script in them. Linux people would never do anything ugly and horrible like that. You're the reason the web is a mess. But Linux people totally do it too. And so since HTML is not a programming language and you have to have some code, they just stick it in the HTML, like JavaScript or PHP inside the HTML. So that means you have files that are just static pages to serve up, and you have other files that are scripts to be run. And how is your server supposed to know? Well, the answer is it just looks at the file name. And if the file name has PHP, it says, oh, that's a script, I'll run that. And if it has HTML, it says, that's not a script, I won't run that. So all I have to do is do the same thing. I can write text into a file. I can get my page back. Here we are. So all I can do is test221.php. And now I can put active code in there. And the code to put in, we got it down here, is a PHP shell. Here, PHP shell. There we go. That's the code to put in. Okay. So now, if I put in that code into that file, this is active code. This less than question mark PHP begins the PHP code, and the question mark greater than ends the code. And what's inside here is the active code. And what this will do is take a parameter called CMD and run it as a shell command. That's what this does. This is considered horribly dangerous, bad PHP. I say PHP is famous for making your server get hacked. PHP has all these dangerous things you really shouldn't do, like running shell commands as an option. And so this is active script, and I'm putting it in a file called test221.php. So when I run that, it didn't crash. So now I have a file called, this was test221.htm, but I now have one called test221.php. Now, when I run that, I get a bunch of ugly error messages because I've deliberately configured my server with visible error messages, which, by the way, is something you're never supposed to do. Because it helps the attackers. But of course, this is a test server intended to get hacked. This tells you undefined index CMD. This is now a code. It's supposed to be running a command. I have to put question mark CMD equals like ls. Now it'll run ls, and I get the list of files on the server, which is stuff random students have put up there. Yeah, everybody will be up there. Kill these. Yeah, everybody's. So now you can do anything you want. You can do ls. You can do semicolon, who am I? And what date? And echo. Pwn. You can put whatever you want here, and it will execute all those commands. So here's the list. Here's who am I, www data. Here's the date. Then it echoes own. You can now execute commands on my server up to the abilities of this permission. Now, this user is the Apache user, www data, and it's not very powerful. So if you actually want to like take over the server completely, you got to escalate to root, which is actually not that hard to do. And if you're taking 124, you'll totally learn ways to do it, because that's a kernel exploit, and there's new kernel exploits about every 3 months for both Windows and Linux. So unless you've been updating your stuff very promptly, there are known ways to escalate to root from a low privilege account like this, but until that's the next step. But anyway, that's command injection. You can now execute commands on my server, which is why it was down. It's going to be down a lot. Like I say, when the semester gets going, people hack my server a lot for some reason, and it tends to go down a lot. So if you're trying to do your homework and the server is down, just let me know, and I'll bring it back up. 2 of them are down this week, which is a good sign. That means people are doing their homework. You can totally mess with my server, obviously. Now they're all back up, but 2 of them are down for a couple days.
In other words, you're saying check the status before you complain.
Well, let me know. The thing is, there's a bunch of them, and they're all getting hacked like crazy when students are doing their homework. So if you try to do the homework and you can't reach the server, don't be too surprised, but let me know and I'll bring it back up. 124 is advanced ethical hacking. So 123 is the beginning attack, and 124 is where you do the more advanced stuff like this, where it is no longer a matter of using a canned tool like Metasploit, but it's a matter of Googling and finding specific tools and sometimes modifying them. It's a little bit of programming, not much, but you're doing a little bit of customizing attacks.
Should I have done that before doing this class?
No, because this class is specifically web apps. But it is where you learn to do that sort of thing. We have a bunch of security classes where you learn different types of attacks, but it's not required for this class. But that would be the next step if you want to get root on that server. Good. I'm glad that question brought it. Anything else?
How about clogging the server. So if you make enough users, at some point the disk space will be full. Any stories on that?
Yes, these are many denial of service attacks. We were doing some at red versus blue. There are many, many attacks that just freeze up the server by using up the CPU, the network bandwidth.
Can you set the file so if instead of being like 50K, now you're like 5,000
Yes.
gig?
Yes.
Or you do it as a script versus just, oh,
Yes.
here's a picture and it's 27K.
There are a bunch of them. There's fork bombs. Fork bombs are code which causes more and more code to run until it uses up all the CPU. What you're talking about is more like a zip bomb. You can make a zip file that will unzip into something unthinkably huge, like 1,000,000 exabytes, so that it can, whatever code tries to unzip it will crash the server. There's a bunch of these. Yeah.
We wanted that fun to be programmed, and this for a bunch of either dev zero or dev random. You random.
Yeah, you can do that. You can do DD and take input file from an endless random number generator on the server and just write to a file until it fills it up. There's a bunch of them. There's simple commands that will use up all the resources on the server.
Stories of people doing it.
Oh, wait, because they're not very cool. These are old script kiddie tricks. It's considered more cool to actually take over the server so you control it. Just destroying the server is also an option, but most people sneer at that. Yeah.
Do you recommend doing the CS department in the Linux system administration class?
I've heard it's very good. Yeah. Although the guy who was really famous just retired, so I'm not sure who's doing it now. But in general, the Linux classes, Linux is very good to know.
It's actually one of your guys' students, the CNIT.
Oh, okay. Might be.
The guy that's doing the Microsoft Cloud class.
Oh, really?
Yeah.
Trust I heard.
Oh.
One of them. There's two of them. They're doing the cloud.
Well, anyway,
One of them.
Linux server administration is a very good thing. I'd be surprised if those guys were doing it because they're mainly Microsoft guys. But anyway, Linux server administration and Bash shell scripting are very good things to know. I just, I know we had a very famous teacher doing that who just retired, so I'm not sure who's doing it now. Peter Wood retired a while ago, and there was another guy just retired. Anyway, I'm going to stop the share, and I'll go up to the lab and help people, and I can answer more questions like this up there. But let me end the recording.